All right, I think this is one of the last assignments before we get into our reviews and practice tests. So we will see a flurry of different questions here, some dealing with probabilities, some dealing with tables, some dealing with tree diagrams, all of the above. So let's just take it one at a time. Again, have your formula sheet handy. You probably need some of these formulas to be successful. Okay, question one. Given the information, what's the probability that a student selected at random will be a soccer player who wears Adidas shoes? So the question is, the probability is a soccer player and Adidas. All right, so we have potential things that we could have. So soccer players, people who wear Adidas shoes. We could have soccer players given that they wear Adidas shoes, or we could have the probability of Adidas shoes given that they're already soccer players. So these are the potential tools that we would need. Let's see what we have here. 4% of the student body plays soccer, so that would be the probability of being soccer. 12% wear Adidas shoes. Okay, 12% of the students who wear Adidas shoes are soccer players. So given that we know that every single one of that category, every single one of those people wear Adidas shoes. So of the students who wear Adidas, who are soccer players, and so that would be this bottom 12%. Given that they are, excuse me, as I wrote. Oh, got you. It's this one. Given that they wear Adidas shoes, so of the students who wear Adidas, given that they wear Adidas shoes, this many of them are soccer players. 19% of soccer players wear Adidas shoes. So given that they are a soccer player, who wear Adidas shoes, that'd be 19%. Okay, now we have a couple different potential possibilities and formulas that we could do here. We could do the probability of S times A, or we could do the probability of A times S. So what narrows that down for us is, notice that we do not have the probability of A. We don't have that. So that takes this formula out of the question. So this is what we would have to do to be success. So the S times the A given X. So this was just kind of extra information that we didn't need. It was just there as a distractor. Okay, again, E-3 means I move it backwards 3 places, so that'd be 0, 0, 7, 6. Again, I'll explain this on the side here. If I have 7.6 E-3, that means I move the decimal place 3 places, making this number smaller. So movement 1, movement 2, movement 3. So that would be 0.0076. That's E-3. Okay, there are 20 students trying out for basketball, a basketball team of 10. How many different teams can be formed of this 20? So N is 20, R is 10. Now, does the order matter in which they are being selected? All right, so here's our basketball team. There's a basketball team of 1, 2, 3, 4, and 5. Is that different than a basketball team of 5, 3, 4, 2, and 1? No, those are the same thing. It's the same team. It's the same team. The order in which I select these people doesn't matter. Okay, the order doesn't matter. Making this a combination, a committee, the order doesn't matter. And so this would be N, C, R. So how many different basketball teams could I make? a bunch. 184,756 different teams I can make. A dial combination has a lock that has a three-number combination. Assuming that the same number can only be used once in this combination, how many different combinations can exist if there's 15 numbers on the dial? Okay, so the numbers can't be used. So there's 15 numbers, and I need to choose 3 of them. So there's going to be a number there, there, and there. And so on a dial lock, okay, okay, on your dial lock, does the order matter in which those numbers come? Yes, the order does matter. Okay, I have to get the sequence right to have that thing unlocked. That means the order does matter. That makes it a permutation. So that would be 15 permute 3. So there would be 2,730 different potential combinations that would unlock that lock. On to tree diagrams. There's 3 questions. Each question is multiple choice with options A, B, and C. Create a tree diagram that shows all of the correct outcomes. Again, your first choice isn't doing question 1, question 2, question 3. That would be incorrect. Again, you have to see how many options do I have. So if I'm taking 3 questions, each question has an A, B, and C outcome. So there's 3 potential outcomes with question 1. 3 potential outcomes with question 2, 3 potential outcomes with question 3, making a total of 27 different answer keys that could be potentially correct. So again, a correct answer could be B, A, C, or something like that. So again, there's 3 options, 3 options, 3 options, making 27 grand total options in this particular problem. Here I have to write really small in this case. So 27. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay. I don't think you'll get one this big on the test, but it's a big outcome. Okay, and that was all for question 3. Let's see if I can do this. This is ridiculous. It's a little hard here. Yeah, you get the idea. All right. So, it'll get smaller real fast. It'll get smaller real fast. All right, so the middle is on the B, 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 the middle is on the B. A, B, C, 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 A, B, C. Okay, so that was question 3. Question 2 is A, B, and C. Again, this is question 2. On to question 1, which is A, B, and C. So again, if I take a look at any one of these potential answers, it will be something that would be truthful. So this would be B, C, B. That could be a potential answer to one of these quizzes. Not like question 1B or something like that. Question 5, you're taking a 4-question true or false test that you haven't studied for. If you're purely guessing on the abilities, make a tree diagram, displays all the different. Okay, so here we got 4 questions, each true and false. So potential outcome to this answer would be false, false, true, false, which I have 2 options, 2 options, 2 options, 2 options, making a grand total of 16 total options. So 16 total options, with the last option being true or false. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is of question 4. Families of 2. This is question 3. Again, this is question 3. On to question 2. Back to question 1. That's where you start. All right, so again, one of these potential answers is exactly a legit answer that could be on the test. I could potentially get the test right if I just were to purely guess that answer. Yes, it's 1 out of what? It's a 1 out of 16 total options. Okay, it's a 1 out of a 16 total option, but it is an option that could be potentially correct. Again, not question 3 false. All right, so these are how you handle those test questions.